See, how many ways to write solid program? How many ways? 3 ways. First one, by implementing Jakarta dot solid interface. Second one, by extending Jakarta dot generic solid class. Third one, by extending Jakarta dot solid dot HTTP solid class. Okay. There are 3 ways to write solid program. First one, this one, solid interface. Second one, generic solid. Third one, HTTP solid. Okay. If we implement solid interface, how many methods mandatory? 5 methods mandatory to override. If we extend generic solid, 1 method mandatory. That is service method. If we extend HTTP solid, no method mandatory. But we have to select. Okay. What are the methods I given yesterday? One is do get. Next, do post. Next, service, which takes HTTP solid request, HTTP solid response. One more, service, which takes solid request, solid response. Okay. See, if we implement solid interface, 5 methods compulsory, you have to override. There is no other alternative for methods. Okay. If we extend generic solid, there is no alternative, 1 method mandatory, that is service method. If we extend HTTP solid, here alternatives are there other than service. You can override do get also, do post also, service also, this service also. But in this all, which is lifecycle service method? Third one or fourth one? Which one? Fourth one. Web container knows only this one. Web container knows only this one. Okay. Web container doesn't know other methods. Web container knows only this one. Clear? But if I override these methods, how it is going to be executed? I'll explain. First of all, what's the difference between these 4? I'll explain. Note down. Do get method. Note down. It handles get type requests. It handles get type requests only. It handles get type requests only. It handles get type requests only. Do post method. It handles post type requests only. Do get method, it handles get type requests only. Do post method, it handles post type requests only. It handles get type requests only. It handles post type requests only. Service method. It can be any service. It handles both get and post type requests. So do get method handles get type requests only. Do post method handles post type requests only. And service method handles both get and post type requests. It handles only get type requests. It handles only post type requests. It handles both get and post type requests. See, do get, do post, service. Do get, do post, service. In these three, you observe. If you override do get, suppose if you override do get, it handles only get type. If post type request comes, it will not handle. Do post, it handles only post type request. If get type request comes, it will not handle. If you override service, both can be handled. But service also, two service methods are there. One is life cycle service method, one is non-life cycle service method. If I override do get, do post, how it is going to be executed? Because web container knows only one method, that is life cycle service. It doesn't know other methods. But how it is going to be executed, I'll explain. See, actually, do get, do post, these all service methods, non-abstract methods in HTTP solid class. I given yesterday. Here, Java P Jakarta dot solid dot HTTP solid. You observe, here I given yesterday. Do get, see, it is non-abstract. Do post, non-abstract. Life cycle service, non-life cycle service, non-abstract. Okay, these are concrete methods. See, but web container knows only this service method. It doesn't know other methods. But how these, if you override other methods, how it is going to be executed? That is, I'll explain. See, web container calls. Web container calls service method, which takes solid request, solid response. Okay. Web container calls this method. In this method, it is non-abstract method. Already some code written. What this method will do is, it calls non-life cycle service method. It calls another service which takes HTTP solid request, HTTP solid response. It is also non-abstract method. In this method, already they written to check. Requester type. If the requester type is get, do get method called. If the requester type is get, do get method is going to be called. If the requester type is post, do post method is going to be called. If the requester type is do post, then post method is going to be called. Here, if the requester type is get, then it calls do get. If the requester type is post, then it calls do post. See, these all non-abstract methods, already some code written. Web container calls this service method. This service method is called life cycle service method. Life cycle method. This service method is called non-life cycle method. Non-life cycle method. See, web container knows only life cycle methods. So web container calls this service method. This service method calls this service method. This service method checks the request type, which type of request came. If it is get, to get calls. If it is post, it calls do post. Like that code already written. Like that it is going to be executed. First you write this one. So web container calls life cycle service method. Life cycle service method calls non-life cycle service method. And non-life cycle service method checks the request type. Which type of request came? It will check. If it is get, it calls do get. If it is post, then it calls do post. Like that mechanism already developed. Now, if you override how it is going to be called, we'll see now. For that, core Java runtime polymorphism, dynamic polymorphism. You study now? Remembered? We'll see now whether you remembered or not. Okay. See, that knowledge required to understand this one. Runtime polymorphism, dynamic polymorphism. That knowledge required to understand this one. Is it over? See, this execution flow, remember, execution flow. Web container calls lifecycle service method. Lifecycle service method calls non-lifecycle service method. Non-lifecycle service method checks the request type. If the request type is get, then it calls do get. If the request type is post, then it calls do post. Okay, like this mechanism already developed in HTTP solid class. Now I'll ask questions. Give me answer. For that, core Java knowledge required. Suppose now don't write. I'll give notes. Just give answers. It is HTTP solid. Okay. HTTP solid. I'll inherit in my solid. It's our solid. See, HTTP solid inherited in my solid. It's our class, user defined class. Here already do get method is there. Do post method is there. And service, non-life cycle service. service, life cycle service. Like this we have. Okay. Suppose in my solid, if I don't override any method, now, if you don't override any method also, program successfully compiled. Because no method mandatory to override, no? No method mandatory to override. So, no need to override. If you don't override any method, program successfully compiled, successfully executed, error will not come, exception will not come, output also will not come. Okay? No output, no error, no exception. Nothing. Because according to syntactically, perfect, it is right. That's what, no error, no exception, no output. Now, then what will be happen, just you observe. Suppose get type request came. Get type request came to my solid. Get type request came. Then it will search for life cycle service. Not there. Then it will search in superclass. This life cycle service called. This will call this one. This will check the request type. Which type? Get. Then do get called. Okay, stop it. Suppose post type request came here. Post type request came. Again, my solid executed. In my solid, it will search for lifecycle service, not there. Then superclass. And lifecycle service calls non-lifecycle service. It checks the request type, post. Then do post call and stop it. This is if you don't override any method. Okay. Now, if you override, what will be happen? See, suppose I will override do get. This method I overridden here. Now, request comes to my solid. Get type request came to my solid. Okay. My solid object. Who will create? Are we creating? No. Who will create? Web container creates. After creating my solid object, with that object, it will search for life cycle service method. Is there? Is there in my solid? No. Then where it will search? HDB solid. This is called. Next, what will happen? It calls non-life cycle service. Okay. It is called. What this service method will do? It checks the request type. Which type request came? It will check. Which type came? Get. Then it calls do get method. Which do get method called? My solid do get or HDB solid do get? Give me answer. Which solid? My solid do get called. Okay. My solid do get called. Because it is overriding method. That method overridden here. That is only runtime polymorphism. If the method is in subclass called. Not there, superclass called. Okay. So if you write get, what will be happen? First life cycle service, then non-life cycle service, then our do get method called. This is the execution flow. Now this do get method not called. Now this method called. Because that is only dynamic polymorphism. Runtime polymorphism. Okay. Dynamic binding. After creating object, binding done. Now, suppose here do get only overridden. I overridden do get only. Here post type request came. Assume. Here post type request came. Now my solid object created. After creating my solid object, what it will do? It will search for life cycle service in my solid. It is there? No. Then where it will? HDB solid life cycle service. Then what it will do? It calls non-life cycle service method. What this will do? It checks the request type. Which type request? Post. Then which method calls? do post. Which method do post? HTTP solid do post. Then this program is not executed. Our method is not executed. Then what will be happen? Do post method call. Then one error message comes because in this method just error message written. If not matched, executed. That's what error message written. What they written is post. This related error message. Post method cannot handle do get. Post type request cannot handle do get. Like that error message written. But our program is not executed. That is the reason. If you want to handle get type request, then only you have to override do get. Okay. Suppose I'll override do post. Suppose I'll override do post. Now get type request came. Assume get type request came. Then what will happen? Now get type request came to my solid. First what will happen? Life cycle service. What this will do? Non-life cycle service. Next request type. Then which method called? Which one? Do get. It is called. But this is not executed. Suppose post type request came. Then life cycle service, non-life cycle service, do post. Which do post? My solid do post. Got it? Suppose I'll override non-life cycle service. Non-life cycle service. Now get type request came. Get type request came. Get type request came. First what will happen? My solid object created. Then life cycle service. Next, which non-life cycle service? HTTP solid or my solid? My solid. From here it calls. After this, is it do get called? Is it do get called? No. Here only stop it. That is our method. In that method, I am not writing to call do get. Here only stop it. So if get type request comes, life cycle service call, it calls non-life cycle service, and it is not going to check. It is our method now. It is our method. That method they will check. This method body written like that, but this method body I am not writing. So this service, after that this service, and stop it. Okay. If post type request comes, what will happen? Give me answer. First, which method called? Life cycle service. Next, which non-life cycle service? My solid life cycle, non-life cycle service. With this, stop it. Here only stop it. Okay. Other methods not executed. Now, if get type also, it will handle. Post type also, it will handle. Suppose, that's what. Now, if you want to handle only get type requests, which method you have to override? Do get. If you want to handle only post type requests, which method you have to override? Do post. If you want to handle both, non-life cycle service. Suppose I'll write life cycle service. Now, get type request came. My solid object created. Next, which one called? Life cycle service. Which life cycle service? My solid or HTTP solid? My solid. After that, it is stopped here only. That is not called. So, if you write life cycle service, then no difference between generic solid, HTTP solid. Because here solid request, solid response. You cannot access HTTP solid request, HTTP solid response. So, that's what we should not override life cycle. This is we should not override. Either override this one or this one or this one. But don't override this one. If you override this one, then no difference between life cycle, generic solid, HTTP solid. Okay. So, if you want to handle only get type requests, which one you have to override? Do get. If you want to handle only post type requests, if you want to handle both non-life cycle service, but you should not override this one. If you override this one, no difference between generic solid, HDB solid. Suppose if I override life cycle service as well as non-life cycle service, both if I override, what will happen? Give me answer. I'll override both. Get type request came. What will happen? Which one called? Life cycle service. Which life cycle service? My solid. After that, give me answer. Now, after this life cycle service, is it called or not called? Not called. Here only stopped. It is no use. Writing this one is waste. It will not call this one. That logic here written, not here. That is how we are writing. Okay. So then what will happen? If you override two methods, what will happen? Then no difference between generic solid and HDB solid. Again, same concept. Okay. Suppose if I override all methods, what will happen? If I override all, again same. Only this one called and stopped. Remaining three methods are wasted. Got it? That's what other combinations are not suitable. Only three combination. You want to handle only get type, do get. You want to handle only post type, do post. You want to handle both non-life cycle service. And some situation, one more combination possible. Do get, do post. Both you can override. Both. Now, get type request comes. What will happen? Life cycle service. Next, non-life cycle service. Next, do get. Which do get? My solid do get. And stop it. Post type request came. Life cycle service. Non-life cycle service. Next, do post and stop it. If you want to handle both, task is different. Get type purpose one code, post purpose another code. In that situation, this is also you can override. Okay. Now, like this, you have to select. Now, no done. To handle only get type requests, override do get method. To handle only get type requests, override do get method. To handle only get type requests, to handle only get type requests, override do get method. We'll override this one. If get type request comes, handled, it is executed. If post type request comes, not executed. Write this type. To handle only get type requests, override do get method. To handle only get type requests, override do get method. See, get type request comes, it is executed. Post type request comes, it is not executed. Okay, that's what. If you want to handle only get type requests, use this. Okay. Is it over? Now, next. To handle only post type requests, override do post method. To handle only post type requests, override do post method. Get type request comes. Is it called? No. Post type request? Yes. Right, like this. So if get type request comes, it is not executed. Post type request comes, it is executed. Okay. It did do post. Is it over? Next. To handle both get and post type requests, and if the task is same, then override non-lifecycle service method. To handle both get and post type requests, and if the task is same, then override non-lifecycle service method. To handle both get and post type requests, to handle both get and post type requests, and if the task is same, then override non-lifecycle service method. So it is also called, it is also executed. Both are executed. To handle both get and post type requests, and if the task is same, then override non-lifecycle service method. So get type request comes, it is executed. Post type request comes, it is executed. First it calls lifecycle service. From that, it will call this one. At last executed. Is it over? One more combination. To handle both get and post type requests, and if the task is different, then override both do get and do post methods. To handle both get and post type requests, and if the task is different, then override do get and do post methods. To handle both get and post type requests, and if the task is different, then override do get both over do get and do post methods. So what you can do is do get. Do post. If the request type is get, it calls this method. It is executed. If the request type is post, then it calls do post method. It is executed. So one program for both get and post type requests, but task is different. In that situation, we can use like this also. So like this also you can write. See, if you want to handle only get type requests, which method you have to select? Do get. If you want to handle only post type requests, do post. You want to handle both, task is different. Task is different. Do get and do post. If the task is same, non-life cycle service. Like that you can select. Okay. Now, like this, you have to select in HTTP solid. So, if we implement solid interface, you must override 5 methods. If we extend generic solid, you must override lifecycle service. If you extend HTTP solid, no method mandatory, but you have a freedom to select methods. According to your requirement, you can choose whatever you want. That is a facility given with HTTP solid. And also, HTTP solid requests HTTP solid response. Subclasses, subinterfaces, super interface methods also you can access with this all. That's what generic solid services you can access. HTTP specific service also you can access. That's what HTTP solid is best option. Previous programs, I taught generic solid. Now, for that application, I'm going to teach from HTTP solid from here onwards. Okay. Is it over? Now, you have seen our task is, I given diagram already. Online students, listen the class, end of the session and clarify your doubts. This is our task. Okay. This HTML completed. This HTML completed. This HTML completed. We have to write 2 solids. Okay. Now, first registration solid required, later login. Registration solid we have to write. When I click on submit button, the value of action attribute executed in a form tag. So then registration solid is going to be executed. But here registration solid, first of all, we have to receive these parameters. Okay. These parameters we have to receive. For receiving solid request required. Solid request. Solid request till I didn't use in the previous programs. We used only solid response. Okay. For that, again, some other knowledge required. Note down. Round down. The object creation order. The object creation order by web container. The object creation order by web container. The object creation order by web container. First one, solid context. Second one, user defined solid. Third one, solid config. Fourth one, solid request and solid response. The object creation order by web container. The object creation order by web container. The object creation order by web container. First one, solid context. Second one, user defined solid. Third one, solid config. Fourth one, solid request and solid response. The object creation order by web container, solid context, user defined solid, solid config, solid request and solid response. One minute. Now, the object creation order by web container, first solid context, second one user defined solid, third solid config, fourth solid request and solid response. See, in previous all programs, we written only service method. Only one method, no? Only service method we written. Now, but in previous all programs also, these all created. These all created. I'll explain. But we didn't use. Till I didn't explain what is context, what is config, what is request, this all. You have seen only solid response. You have seen user defined solid. Okay, you have seen user defined solid. You have seen solid response. That's it. See, in previous programs, what has happened? Just you observe. Now, previous programs, basics. Here you studied 8 programs. You studied 8 programs. These 8 programs you studied basics. Okay. Any one solid. For example, first solid. First solid. Now, in this program, first what will happen is this application deployed. Then only this is created. But what is context and how to use, what is the purpose, this all I didn't explain. But in that program, context created. We didn't use. But what is context, I didn't explain. How to use, I didn't explain. What is the purpose, I didn't explain. But created in the program. Now, when it is created, also you should know. Note down. Solid context is created by web container whenever web application is deployed on server. Solid context is created by web container whenever web application is deployed on server. Solid context is created by web container whenever web application is deployed on server. Solid context is created by web container whenever web application is deployed on server. See, whenever web application deployed on server, then only this is created. When it is created, I given what is that, what is the use, what is the purpose, I didn't explain. That later we'll see. Next, user defined solid object is created by web container whenever first request comes to a solid. User defined solid object is created by web container whenever first request comes to a solid. User defined solid object is created by web container whenever first request comes to a solid. User defined solid object is created by web container whenever first request comes to a solid. See, in our program, first solid is user defined solid. Okay. Previous all solids. Like user defined solid object is created by web container whenever first request comes to a solid. First solid, second solid, counter solid, time solid, table solid, dual solids you have seen, no? Whenever first request comes, then that object created. With that object only life cycle methods are called. So this object is used. Note down. This object is used by web container to call life cycle methods. This object is used by web container to call life cycle methods. This object is created by web container to call life cycle methods. See, application deployed. Application deployed on server. What is created by web container? Solid context created by web container whenever web application is deployed on server. Solid context created. What is context? What is the use? Just after 2-3 days we'll learn. Okay. User defined solid object is created by web container whenever first request comes to a solid. Now, after deploying, whenever you send request from browser to first solid for first request, then created. With that request only, with that object only, life cycle methods are called. When first request comes, how many methods called? How many methods? 2 methods. What are those? Init and service. But where is init method in this program? But not there, no? But generic solid. If the method is not present in subclass, then where it will search? Superclass. In generic solid, init method is there, no? That init method called. That init method called. Okay. In that init method, you have seen already. You have seen jakarta.solid.solid. Here methods I given. It is init method. Init method parameter, what is there? See, solid config. Whenever init method called, config created. After that, service. So here, next is solid config. Note down. Solid config is created by web container whenever init method is called. Solid config is created by web container whenever init method is called. When init method is called, first request only. Init method is called by web container whenever first request comes to a solid. Solid config is created by web container whenever init method is called. Init method is called by web container whenever first request comes to a solid. So whenever application deployed, context created, solid context created. Whenever first request comes, user defined solid object created. With that lifecycle init method called. With that solid config called. Solid config created. After that service method called. Whenever service method is called, these two created. Next. Solid request and solid response are created by web container whenever service method is called. Now, when service method is called, what is that? Every request, not only first request. First request onwards, every request. Write it. Service method is called by web container for every request. So every request response created. Solid request and solid response are created by web container whenever service method is called. Service method is called by web container for every request. Solid request and solid response are created by web container whenever service method is called. Service method is called by web container for every request. Every request service method is called. Now, so previous programs also, these all created. These all created. Okay. Now, I'll ask questions, give me answer. The object creation order by web container. First, what is created? Solid context. Next, user defined solid. Next, solid config. Next, solid request and solid response. Okay. Next, when solid context is created, whenever web application is deployed on server. When user defined solid object is created, whenever first request comes to a solid. When solid config is created, whenever init method is called. Init method, when it is called, whenever first request comes. That means solid config also created whenever first request comes. Solid request and solid response, when it is created, whenever service method is called. Service method, when it is called, for every request created. Every request called. Okay. Now, question different angle I'll ask. Give me answer. Okay. Question different angle. Whatever I given in that only. Answer is there. Now, one web application. No need to write this one. Just listen. One web application has 3 solids. One web application has 3 solids. And total number of requests to these solids, 500. Total number of requests to these solids is 500. Now, one web application has 3 solids. Total number of requests to these solids is 500. That means one solid maybe 200, one solid maybe one more 200, one more 100, maybe like total at last 500 requests. Now, my question, carefully listen and give me answer. How many solid contexts created? I written, you observe, one web application has 3 solids. Total number of requests to these solids is 500. How many? 1 created. Solid context is created whenever web application is deployed. That means dynamic web project. That is like a web application. You take another chair. Here, dynamic web project is like a web application. In the dynamic web project, n number of solids you can place. There is no limit. Okay. Now, one web application has 3 solids. Total number of requests to these solids is 500. Okay. One solid maybe 200, one solid maybe 150, one solid maybe 150, like that. At last total 500. My question is, how many solid contexts created? 1 only created. Okay. How many user defined solid objects created? 3. How many solid configs created? How many? 3. Every solid first request will be there. How many requests and responses created? 500. Every request response. Is it clear now? Remember, don't forget for the record. See, one web application has 3 solids. Total number of requests to this solid 500. So whenever web application deployed, context created. That context common to all solids. And 3 user defined solid. Every solid separate user object created With that only life cycle methods called. Every solid init method will be there, no? Their solid config will be there, no? Solid config, every solid different. But solid context is common to all. Solid config is every solid separate. But request response is there, no? Every request different. Every request it is separate. Okay? Like that. Now, in our program, only this is used in previously. This is and this is. With this, life cycle methods called. With this, streams created to send response, server to browser. Now, present in our task, these all request parameters you have to receive. No? For receiving this data, solid request required now. This is required. This is later, this is later. This is over, this is over, this is required now. Okay. Next, note down. Solid request. It is created by web container for every request. It is created by web container for every request. It contains request parameters. It contains request parameters. It is used to retrieve request parameters from HTML, solid. Okay, just HTML, write it for understanding now. Later you can, with knowledge, you can understand. It is used to retrieve request parameters from HTML. It is used to retrieve request parameters from HTML. It is used to retrieve request parameters from HTML. It is created by web container for every request. It contains request parameters. It is used to retrieve request parameters from HTML. So here in this application, here request parameters you will type. These all we have to receive. That purpose solid request required. That purpose solid request required. Okay. Is it over? Now, the following methods are used to get the request parameters. The following methods are used to get the request parameters. The following methods are used to get the request parameters. The following methods are used to get the request parameters. Now I'll give the methods. One, two, three, four. These four methods required. Note down. The following methods are used to retrieve the used to get the request parameters. These all present in Jakarta.solid request. You written directly write, not a problem, because already solid request heading written. No? Solid request, solid written heading. Note down. Package name, if you write also, nothing will happen. Package names I'm removing. Instead of writing again and again, I'm removing. Here get parameter names, get parameter values, get parameter map. Get parameter names, get parameter values, get parameter map. 4 methods. Here, if you pass parameter name, you will get a parameter value. Okay. These all we'll see later. First, this one we'll see. 4 methods. You studied collections also in core Java, no? Collections, enumeration, collection, map, collection. These two collections related. It is array. This is general, normal. It is collection. It is array. It is collection. Generic type. Generics also studied, no? Core Java generics. That is collections, generics. That is. First we'll see this one. Later we'll see remaining. Here, get parameter. Parameter name you have to pass. Parameter value comes. Suppose in this diagram, for this box name, already we written in the HTML. What I written? F name. For this box name, L name. For this box name, U name. For this one, P word. Those all are written in HTML program, no? Those all we have to pass here. If you pass F name, whatever you typed, that value comes. L name, whatever you typed, that value comes. U name, whatever you typed, that one. P word, whatever you typed, that one comes. So, this box name doesn't appear in a HTML output. It is there. Already we written. Okay. Here you observe. Here login, src main web app. Here login.html, registration.html. Here I written F name, L name, U name, P word. These are called request parameter names. And whatever you are typing, those are called request parameter values. If you want to get the value, this name you have to pass in this method. If you pass name, you'll get a value. But this method in which interface? Servlet request. Okay. Now we'll see this program. This continuation. These 3 HTML programs completed. Now we are going to write registration servlet. Okay. Listen with more concentration. It is registration servlet we are writing. Now right click, new servlet. Here package name, suppose login. Any other also you can write. Class name, registration servlet. Okay. See, package name login I written. It is not compulsory to write this name same. You can write whatever you want. I written login only. Class name I written registration servlet. Now you studied HTTP servlet. So I'll continue with HTTP servlet now. Now no need to change generic servlet. You continue HTTP servlet. Okay. Now here package name login, class name registration servlet, extends HTTP servlet. After this, click on next. Here URL pattern, edit. Already we written in the HTML program. What we written? reg in small letters. Reg. Okay. See, you already written here. Here action equal to reg was there. Okay. Reg. That is written. Reg URL pattern. After this, next. Here. Now, by default, do get do post method selected. Which type of request coming? Here method equal to post. Which type of request coming? Post. Then which method you have to select? Do post. We don't require this one. We can remove. Do post I selected. Do post I selected. Now do post I'll write. Okay. Do post I'm going to write. Here in this code I'll write in do post. But this data we have to store in database, no? This data we have to store in database. Now do post method. Do post method actually it is non-lifecycle method. Non-lifecycle method. Do post called from which method? Non-lifecycle service. Non-lifecycle service called from lifecycle service. Lifecycle service called by web container. Web container calls lifecycle service. Lifecycle service calls non-lifecycle service. After that, do post call. Do post call. Then your code executed. Suppose first database connection also required. No? Database connection. Database connection. Writing in do post method better or init method better or destroy method better? Init, do post, destroy. Which one is better? Init method. Because connection how many times required? One time. If I write in do post, what will happen? Every request connection established. Whenever user registered, connection established, data stored. Again user registered, again connection established, data stored. Every request connection established. Memory wasted, performance wasted, processor wasted, process wasted, server point of view burden. Okay. That's what you should not write connection establishment code inside the do post. Where we ought to write init method. That's what select init method also. Okay. Connection close. Where we ought to write destroy. Whenever application undeployed. Then required. That's what I selected init for connection establishment. This is for task. This is connection close. 3 methods I selected. Now click on finish. Here code written. So init method came, destroy method came, post method came. Okay. Now our task. First, according to diagram, you see. According to diagram, whatever I typed, these 4 request parameters we have to receive. For this, which method required? Get parameter. Just now I given. Get parameter. This method required. This method in which interface? Servlet request. Is it instance method or class method? For calling this method, servlet request reference required. No? But in our program, HTTP servlet request is there. Can I access with HTTP servlet request? Yes or no? Which is super interface, which is sub interface? HTTP servlet request is a sub interface. Servlet request is a now the method is present in HTTP servlet request or servlet request? Servlet request. By using HTTP servlet request reference, can I access? Yes. What is the return type of that method? String. What we have to write? String. S1 equal to request dot get parameter. Parameter name is fname. Fname. This must match in the HTML program. In HTML program, parameter must match. Next, string s2 equal to request dot get parameter. Parameter name is lname. Next, string s3 equal to request dot get parameter uname. Next, string s4 equal to request dot get parameter pivot. Okay. Now 4 request parameters are received. Okay. Here f name, l name, u name, pivot. All request parameters are received. Okay. All request parameters received. These request parameters we have to store in database. This request parameter we have to store in database. First of all, you have to establish the connection. Connection establishment code where we have to write? Where we have to write? Init method. Okay. Connection establishment code we have to write in the init method here. What we have to write? Class dot for name. Oracle dot JDBC dot driver dot Oracle driver. Okay. Next. Connection con equal to driver manager dot get connection. How many parameters? 3 parameters. Okay. URL, username, password. Next. JDBC colon Oracle colon thin colon at localhost colon 1521 XC. Next. Next. Manager. Okay. Now this class dot for name also not compulsory. JDBC 4.0 feature. Okay. Now here connection. This connection here, this data with that connection, we have to insert this data. This data we have to insert in database. If you want to insert in database, statement or prepared statement or callable statement, which one required now? Statement or prepared statement or callable statement? Which one? Prepared statement, dynamic data, S1, S2, S3, S4, dynamic data received. Okay. Now this connection reference with this, you have to call prepare statement method. Study now. For getting statement interface reference, which method you'll call? For getting statement reference, which method you'll call? Which method? Create statement. For getting prepared statement, which method? Prepare statement. For getting callable statement, what is that? Prepare call, not get callable statement. Okay. Prepare call is there. First one, create statement is there. Second one, prepare statement is there. Third one, prepare call is there. Okay. But if you want to call, first this connection reference, is it instance connection object reference, connection reference? Can I call variable? Now this object reference, can I call variable? Yes or no? Is it instance variable or class variable or local variable? Now, is it instance variable or class variable or local variable? What is? Local variable inside a method. Inside a method. Can I access this variable here? No. That's what this is you have to declare as a instance variable. Outside I'll write. Outside. Okay. Now, this connection reference con. Now, is it instance variable or class variable or local variable? What is? Instance variable. How many ways to access instance variable? What are those? Which class object required to call? What is that? Registration solid. This object required to call. That object who will create? Web container creates. But that object how to access? Object we cannot create, no? We are not going to create. Object is created by web container. Object is created by web container. With that object, we have to access connection. How to access? Now, is it instance variable or class variable or local variable? That is clear, no? Still any doubts are there? That is instance variable. How many ways to access? What are those? Which class object required? RAG solid object required. That object who will create? Web container creates. That object how to access? What is it? How to access that object here? We are not going to create. We should not create. Web container creates. That object data we have to access. How to access? This keyword only can access, no? Current object. This keyword. This keyword also no need to write. Implicitly this keyword present. Here. This dot. Implicitly present. No need to write. Don't forget core Java. Okay. This dot. This implicitly present. No need to write by us. Here also this dot implicitly comes. Now. Here this dot we have to write. This dot, this implicitly comes. Prepared statement PSTMT equal to connection dot prepare statement. Here we have to write query. Okay, we have to write query. What we have to write here? This query we have to insert in database. Table name uinfo. Okay, this data we have to insert. We have to create one query. What we have to write? Insert into uinfo values. How many question marks? 4. First name, last name, username, password. 4 question marks. Now this data we have to fill. How to fill? Now question marks we have to fill, no? How to fill? Which method you have to call? Setter methods. What do you have to write? Set string. First question mark S1. Next set string. Second question mark S2. Next PSTMT dot set string. Third question mark S3. Next set string. Fourth question mark S4. Now which method we have to call? Which one? Execute update. Execute update. Now that query executed, data inserted in database. After this, you have registered successfully login hyperlink. For that, what we require? Print writer require, no? Print writer response dot get writer. PW dot println. You have registered successfully. Okay, you have registered successfully. After this, login hyperlink required. Login hyperlink. Hyperlink, which tag will write? Anchor tag. Anchor tag close. Here, login. When you click on login, hyperlink reference. Login.html. Login.html. This anchor tag, if you want to write some other HTML tags also, you have to write. I'll write some other tags here. pw.println, HTML, body, BG color, suppose red, text, suppose yellow. Okay, center, whatever you want, you can write. That is, you can design later. Now, here, suppose level 1 heading. Level 1 heading, close. These all we have to close. Center close. Body close. HTML close. Okay. Now, one brace extra is there. One. Now here, try catch blocks. Here, destroy method. Here, connection we have to close. Connection dot close. This will also throws exception. So you have to handle try catch blocks. Okay, but here one error is there. 1 minute. Here also exception handling required. Now. Okay, I didn't change anything. It is worked. Okay, that is it is taking some time to recognize that is happening. See, first here this table should exist in database. No, info table. We have to create table. The table already present, I think, in previous batch. I taught same table. Okay, already is there. I'll remove. Otherwise, the table only will continue. Here already registered table is there. This table is there. Okay, this table is there. Now I'll register with one more name. Okay, see. Right click. Now run on server. Save. Localhost Tomcat. Next. Finish. Now here homepage.html. Homepage.html. Now registration. reg.html. Here already 3 users registered. Okay, now I'll enter triple D. See, triple D. Like this. If I click on submit button, here what we are getting error, you see, connection not established here. This dot connection is null. Reason the JDBC, OJDBC jar file is there, no? That is we have to attach. That is we have to attach to this application. So right click, build path, configure build path, class path, add external jar, C drive, Oracle XE, app, Oracle, product 11.2.0 server, JDBC lib, OJDBC 6_G. You can attach like this. Otherwise, you can copy into Tomcat lib folder. That is also works. Right click, run on server. Restart the server. homepage.html registration, say triple D, triple D, triple D, triple D. If I click on submit button, 1 minute. Otherwise I'll copy into Tomcat server. C drive, Oracle XC, app, Oracle, product 11.2.0 server, JDBC, lib. So in a Tomcat lib, directly you can paste here. It is also possible, another way. Now, this is server, we have to stop, we have to restart. Right click, run on server. Here, homepage.html. Registration. See, you have registered successfully. Okay. Now, here, you can check here, like this, stored. But it is registration solid. Still, login solid, we have to write. It is not completed. That in next class we'll see. This program also in next class you can write. Okay. Tomorrow is a holiday. Tomorrow no class. You will see continuation day after tomorrow. Happy Ugadi to all. Thank you. We'll see continuation day after tomorrow.